students, in this session we'll start to understand about epistasis as an example for non-allelic gene interaction. And here in the previously we discussed about the complementary genes action. Here this is something different. No doubt in this case also two genes are involved, where one gene will interact with another gene in a different way. How is that? Let me tell you by making a statement. I'll write it here. Epistasis is a phenomenon of interaction between two non-allelic genes. Non-allelic genes where one gene masks or inhibits the expression of other gene. So what is that? Epistasis is a phenomenon, or it is a case where there is an interaction between two non-allelic genes, where out of these two maybe both are dominant or may not be. Allelic genes belong to the different locus where one gene masks or inhibits action of another gene. I show you with this diagram so that you will be able to understand it very clearly. Once again, pair of genes where one is paternal, another is maternal. Here we are discussing about two kinds of genes. One gene locus is here. Let us say it is capital A. Another gene locus, that is here. This is capital B. See here, A is belonging to one locus, B is belonging to another locus. Their corresponding alleles could be either small a or capital A. Its corresponding allele belonging to the same locus could be either small b or capital B. Since it is non-allelic gene interaction, A needs to interact with B or B needs to interact with A. Please remember. But during this interaction between A and B, there is a definite pattern where this dominant gene, okay, it really masks the expression of another gene, that is capital B. Means A is inhibiting the expression of capital B. So this way, this capital A is said to be epistatic gene. This capital A is said to be epistatic gene. Whereas this capital B, which is being masked by the epistatic gene, is called hypostatic gene. Just in a layman language or in a humorous way to say, this is one dominant gene A ಮತ್ತು B ಒಂದು dominant gene, but ಬೇರೆ ಲೋಕಸ್ ಮೇಲೆ ಅದಾವ on the same chromosome ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ ಕ್ಯಾಪಿಟಲ್ A ಜೀನ್ ಇದ್ದಂತದ್ದು ಕ್ಯಾಪಿಟಲ್ B ನ ಕಂಪ್ಲೀಟ್ಲಿ ಮಾಸ್ಕ್ ಮಾಡ್ತೈತೆ. ಅಂದ್ರೆ ಜಸ್ಟ್ ಲೈಕ್ ಇನಿಬಿಟಿಂಗ್, ಅಂದ್ರೆ ಅದರದ್ದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಕಂಪ್ಲೀಟ್ಲಿ ಸಪ್ರೆಸ್ ಮಾಡಿಬಿಡುವಂಥದ್ದು. ಅಂದ್ರೆ A ಸಮಥಿಂಗ್ ಲೈಕ್ ದಾದಾಗಿರಿ ಜೀನ್ ಅಂತ ನಾವು ಕರಿಬಹುದು. Whereas B ಇದ್ದಂಥದ್ದು ದಾದಾಗಿರಿ ಮಾಡಿಸಿಕೊಳ್ಳುವಂಥದ್ದು. ದಾದಾಗಿರಿ ಮಾಡುವಂಥ ಜೀನ್ಗೆ ನಾವು ಎಪಿಸ್ಟಾಟಿಕ್ ಜೀನ್ ಅಂತ ಕರಿತೇವೆ. ಅಂದ್ರೆ another one that is being masked ಅಲ್ಲ, ಅಂದ್ರೆ ದಾದಾಗಿರಿ ಮಾಡಿಸುವಂತ gene, that is B, is said to be hypostatic gene. Just for your understanding I use this example, but please don't mean it literally. So this is a concept exactly. Then the elaboration of the same concept is that here I say epistatic gene, is it to be present all the time in a dominant state or not? It depends. If an epistatic gene present in a dominant state, then it is called as dominant epistatic gene. Dominant epistatic gene. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೇಕು. ಎಪಿಸ್ಟಾಟಿಕ್ ಜೀನ್ ಅಂತ ಅಂದಿವು ಅಂತಂದ್ರೆ ಅದು ಡಾಮಿನೆಂಟ್ ಅಂದ್ರೆ ಏನು, ಡಾಮಿನೆಂಟ್ ಅಂಡ್ ರಿಸೆಸಿವ್ ನಿಮ್ಗೆ ಗೊತ್ತು. ಡಾಮಿನೆಂಟ್ ಸ್ಟೇಟ್ ನಲ್ಲಿ ಇತ್ತು ಅಂತಂದ್ರೆ ಅದಕ್ಕೆ ನಾವು ಡಾಮಿನೆಂಟ್ ಎಪಿಸ್ಟಾಟಿಕ್ ಜೀನ್ ಅಂತ ಕರಿತೇವೆ. ಅಂತ ಫಿನಾಮಿನಾನಿಗೆ ಡಾಮಿನೆಂಟ್ ಎಪಿಸ್ಟಾಸಿಸ್ ಅಂತ ಕರಿತೇವೆ. ಸಮ್ ಟೈಮ್ಸ್ ಏನಾಗ್ತದೆ, ಅಲ್ಲಿ ಡಾಮಿನೆಂಟ್ ಇರದೇ ಇರಬಹುದು ಎಪಿಸ್ಟಾಟಿಕ್ ಜೀನ್, ಇಟ್ ಮೇ ಬಿ ರಿಸೆಸಿವ್ ಆಲ್ಸೋ. ದಯವಿಟ್ಟು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೇಕು. ಇಟ್ ಈಸ್ ವೆರಿ ಸ್ಪೆಷಲ್ ಕೇಸ್. ರಿಸೆಸಿವ್ ಎಪಿಸ್ಟಾಟಿಕ್ ಜೀನ್ ಹಂಗಂದ್ರೆ ಏನು? Recessive epistatic gene is an epistatic gene where its one allele, I mean one or both, are in recessive state. ಅದರ ಕ್ಯಾಪಿಟಲ್ ಎ ಬದಲಾಗಿ ಇದಕ್ಕೆ ನಾವು ಕ್ಯಾಪಿಟಲ್ ಎ ಅಂತ ಬರ್ದೇವು ಅಂತಂದ್ರೆ ಇದು ಡಾಮಿನೆಂಟ್ ಎಪಿಸ್ಟಾಟಿಕ್ ಜೀನ್ ಆಗ್ತದೆ. ಅದೇ ಆ ಡಾಮಿನೆಂಟ್ ಇರೋ ಬದಲಾಗಿ ರಿಸೆಸಿವ್ ಇದ್ರೂ ಕೂಡ ಎಪಿಸ್ಟಾಟಿಕ್ ಜೀನ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡ್ತದೆ when it is present in a recessive state, that is kept small a. ಅವಾಗ ನಾವು ಸ್ಮಾಲ್ ಎ ಅಂತ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ಇದನ್ನಕ್ಕೂ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟು ನಾವು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ತಿದೀವಿ. ಇದಕ್ಕೂ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಗೆ ಇನ್ನೊಂದು ಬೇರೆ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡು ನಾವು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ತಿದೀವಿ. Today we are going to learn or understand about how exactly the dominant epistatic gene behaves, how the dominant epistasis occurs, by taking an example for our understanding. Let us take an example. One trait, ಅದು ಗೊತ್ತದ ನಿಮಗೆ. ಟ್ರೇಟ್ ಅಂದ್ರೆ ಏನು, ಕ್ಯಾರೆಕ್ಟರ್ಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ. Trait, that is a plumage color in fowls. ಅಂದ್ರೆ ಕೋಳಿ, ನಿಮ್ಗೆ ಗೊತ್ತು. ಪ್ಲೂಮೇಜ್ ಅಂದ್ರೆ ಕೋಳಿ ಪುಚ್ಚ specific color. Based on color of the plumage, we could be able to differentiate the color of the fowl. ಅದು ಹೆಣ್ಣು ಇರಲಿ ಕಾಕ್ ಇರಲಿ, ಅದು ಬ್ರೌನಿಶ್ ಇದ್ರೆ ಬ್ರೌನ್ ಕಲರ್ ಕಾಕ್ ಆರ್ ಹೆಣ್ಣು ಅಂತೀವಿ, ಅಥವಾ ಯೆಲ್ಲೋ ಕಲರ್ ಅಂತೀವಿ, ಅಥವಾ ವೈಟ್ ಕಲರ್ ಅಂತ ಕರಿತೀವಿ, ವೈಟ್ ಕಲರ್ ಕೋಳಿ ಅಂತ ಕರಿತೀವಿ, ಅಥವಾ ಡಾರ್ಕ್ ಕಲರ್ ಕೋಳಿ ಅಂತ ಕರಿತೀವಿ. ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ಕೈಂಡ್ ಆಫ್ plumage, colored plumage they have or they possess ಅಂತ ಹೇಳಿ. So that for example ನಾನು ಹೇಳಿದೆ, ಈಗ ಫಸ್ಟ್ ಅಂಡ್ ಫಾರ್ಮೋಸ್ಟ್ ಒನ್ ಎಕ್ಸಾಂಪಲ್, ದಟ್ ಈಸ್ ಇನ್ ಕೇಸ್ ಆಫ್ ವೈಟ್ ಲೆಗ್ ಹಾರ್ನ್. ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಇಟ್ ಈಸ್ ಎ ಮೆಡಿಟರೇನಿಯನ್ ಬ್ರೀಡ್. ವೈಟ್ ಲೆಗ್ ಹಾರ್ನ್. When we cross this with white, another one variety breed fowl, that is white Vandotek. White ಅಂತ ತಕ್ಷಣ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗಿಬಿಡಬೇಕು ಪ್ಲೂಮೇಜ್ ಕಲರ್ ಇಲ್ಲಿ ಏನಿರ್ತದ ಅಂತ ಹೇಳಿ. ದಟ್ ಈಸ್ ವೈಟ್ ಕಲರ್ ಇರ್ತದ. ಬಟ್ ವಾಟ್ ಮಸ್ಟ್ ಬಿ ಇಟ್ಸ್ ಜಿನೋಟೈಪ್ ಟು ಎಕ್ಸ್ಪ್ರೆಸ್ ದಿಸ್ ವೈಟ್ ಕಲರ್ ಪ್ಲೂಮೇಜ್ ಇನ್ ಲೆಗ್ ಹಾರ್ನ್. ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ಎರಡು ಜೀನ್ ಆಕ್ಷನ್ ಮಾಡಲಿಕ್ಕೆ ಬೇಕು. ಸೊ ಲೆಟ್ ಮಿ ರೈಟ್ ಇಟ್ಸ್ ಜಿನೋಟೈಪ್ ಆಸ್, ವಾಟ್ ಇಸ್ ದಟ್? capital I, then capital C. I explain what is this I and C means. And here its genotype of this white Vandotek will be small I, small c. Fair. Isn't considered one white leg horn. Let us take this. Here this capital I. Now I ಅಂತ ಯಾಕೆ ತಗೊಂಡಿದ್ದೀವಿ ಅಂತಂದ್ರೆ, it is an epistatic gene. Epistatic gene is also called inhibitory gene. Inhibitory gene. This epistatic gene or inhibitory gene mask the expression of its corresponding, different locus located gene as capital C. This capital C is for color of the plumage, means non-white. ಬೇರೆ ಯಾವ್ದಾದ್ರು ಕಲರ್ ಇರ್ಬೋದು, ಇದಕ್ಕೆ ನಾವು ಕಲರ್ ಜೀನ್ ಅಂತೀವಿ, ಅದಕ್ಕೆ ಕ್ಯಾಪಿಟಲ್ ಸಿ ತಗೊಂಡಿದ್ವಿ. However, here the capital I is epistatic to capital C, so that capital C expression, color, plumage, character is inhibited, is masked by the expression of capital I. In this way you can understand, and the location of this capital I on chromosome is said to be epistatic locus, and this is position of this capital C on the chromosome is hypostatic locus. ಅದನ್ನು ನಾನು ಇಲ್ಲಿ ನಿಮಗೆ ಮತ್ತೊಂದು ಸರಿ ಮಾಡಿ ತೋರಿಸ್ತೇನೆ. Here I will write instead of A and B, ಅದನ್ನು ನಾನು ಈ ರೀತಿ ಬರೀಬಹುದು, ಅಂದರೆ ನೀವು ಈಸಿಯಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಬಹುದು. ಅಲ್ಲಿ ಕ್ಯಾಪಿಟಲ್ I ಇಲ್ಲಿ ಬರೀತೇನೆ, its corresponding could be like small I or capital I. Then ಇನ್ನೊಂದು dominant gene, that is gene for color plumage, capital C. ಇನ್ನೊಂದು its corresponding small c ಆಗಿರಬಹುದು, ಅಂದರೆ ರಿಸೆಸಿವ್ ಇರಬಹುದು ಅಥವಾ ಡಾಮಿನೆಂಟ್ ಇರಬಹುದು. Okay, but please remember, this is epistatic gene I, this is hypostatic gene C, located on different loci. Singular is locus, plural is loci. So ಅದಕ್ಕೆ ನಾವು ಇದನ್ನ I is ಅಂದ್ರೆ epistatic ಅಥವಾ inhibitor gene. ಇದು ಎದರ ಮೇಲೆ? This capital C, this is a gene for colored plumage. ಅದರ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಆಗೋದೇ ಇಲ್ಲ. ಅದಕ್ಕಾಗಿ we see all the time white leghorn breed, Mediterranean breed with white plumage color only. Okay, genotypically though that leghorn carries this gene for color, phenotypically it is never found with any specific colored plumage. That's how you can understand capital I and capital C. How do they behave? Neither they supplement each other nor they complement each other. In fact, opposite to each other ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. ಅಂದ್ರೆ ಕ್ಯಾಪಿಟಲ್ I ಕ್ಯಾಪಿಟಲ್ C ಮೇಲೆ ದಾದಾಗಿರಿ ಮಾಡ್ಕೋ ಅಂತ ಅನ್ಕೊಂಡ್ರೆ ಅಂತಂದ್ರೆ ಕ್ಯಾಪಿಟಲ್ C automatically succumbed to get suppressed this way. Then white vandote, ಈ white vandote ದಲ್ಲಿನೂ ಕೂಡ ಎರಡು ಜೀನ್ ಇರ್ತವೆ. ಒಂದು ಬಟ್ ಜೀನ್ ಫಾರ್ ವೈಟ್ ಕಲರ್ಡ್ ಪ್ಲೂಮೇಜ್ ಇನ್ ವ್ಯಾಂಡೋಟೆ ಆರ್ ಇನ್ ರಿಸೆಸಿವ್ ಸ್ಟೇಟ್. ಇಲ್ಲಿಯೂ ಕೂಡ ಸ್ಮಾಲ್ ಐ ಇದೆ, ಸ್ಮಾಲ್ ಸಿ ಇದೆ, ಬಟ್ ಹಿಯರ್ ಸಿನ್ಸ್ ದೇ ಆರ್ ರಿಸೆಸಿವ್ ಇನ್ ಸ್ಟೇಟ್, ಕ್ಯಾಪಿಟಲ್ ಐ always, there is no question of capital I suppressing capital small c, because both the genes are recessive to the colored gene. All the time this white vandote, vandote fowl will be having white color plumage. Okay, when we cross these two so as to obtain the first generation or F1 generation, so look at it, capital I capital C during gamete formation, and here small I small c during gamete formation. Okay, when these two unite together we obtain what? F1 generation. This is a pure line parents, and this is genotype, and this is gamete formation. And here what you get is capital I, small I, capital C, small c. What it could become? Look at it, it is very, very clear that capital I is epistatic to capital C, so that obviously we get white colored plumage, white plumage breed. Okay, with somewhat like a dark flecks. Right? Now we need to know some more, like to know the behavior of this capital I with respect to the corresponding its dominant or recessive allele. Okay, and for that reason we need to cross the F1 generation male and female with white plumage color only, and that with this kind of particular genotype. Okay, and here white plumage of F1 generation, one should be male and another should be female, and another one white only, white plumage. So that I will write female and this must be male, so that here it produces sperms, here it produces ova. Okay, and it produces its genotype, let me write like capital I, small I, capital C, small c, and here small capital I, small I, capital C, small c. Though it is a female, plumage color comes same in F1 generation, so that it produces sperms with 4 different allelic combinations as usual. like capital I, capital C, one set, another one capital I, small c, other set, and here small I, capital C, then the last set, that is a small I, small c. Okay, so that 25% of sperms carrying this kind of genotype, then second 25% with the capital I, small c, third that is with the small I, small I, capital C, and last 25% of the sperms carrying genotype, they are completely recessive, small I, small c. And here also the same in case of ova, carrying their respective 4 allelic combinations like capital I, capital C, and here it is capital I, small c, and here it is a small I, capital C, and a small I, small c, right? So when we cross these two, we get totally about 16 genotypes, and for that reason we need to take care of checkerboard or Punnett square board. Here let us try to do it. By means of this, exactly how the epistatic gene expresses or behaves. So here I do like this, and this side I write male, and this side, this means male gamete sperms, and here it is female gamete. I write ova, and here it is sperms. Right? First allelic combination capital I, capital C, then second is capital I, small c, third is a small I, capital C, and small I, small c. Similarly here also we get capital I, capital C, capital I, small c, small I, capital C, and small I, small c. So that we get 16 genotypes. I write a little bit fastly. There is nothing difficult in understanding this. So make 4 columns and 4 rows. So we get 16 genotypes. So this one, this with this capital I, capital C, capital C. This capital I, capital C, small c. This with capital I, small I, capital C, and this with capital I, small I, capital C, small c, and this with capital I, then capital C, small c, and this one capital I, small c, capital I, small I, capital C, small c, and here capital I, small c, and third row, this is capital I, small I, capital C, then this is capital I, small I, capital C, small c, and this is with small I, capital C, and this one small I, capital C, small c, and the last row capital I, small I, then capital C, small c, and here capital I, small c, then this is small I, capital C, small c, and last one small I, small c, right? Here these are the 16 genotypes where we need to express their respective phenotype. So what I want to do is that totally how many color plumaged fowls we get. Wherever you get a capital I and a capital C, please remember that it becomes white. Why? Because capital I gene inhibits the expression of capital C, so that I will write a small w for white. Here is white, this is white, this is white, this is white, this is white, and this must be also white. The entire column, first column, then this is white, okay? And the second row coming to this, and here you get capital I. Obviously this must be also white, and look at it. Capital I can express only in presence of either capital C or small c. Please remember, without C I cannot express. Then capital here, this must be also white, and this must be also white. Then this is already white, and this must be white, and this cannot be white because it is in recessive state. In case of dominant epistasis, obviously it becomes colored plumage because capital C is not being masked because this is small. The epistatic gene is in recessive state. It cannot. So that this capital C will express its color. So that I will write I will use this this red color chalk for mentioning colored plumage, so that I will write with C. This is colored plumage, this is also with colored plumage, then this is also with colored plumage. Please identify it correctly. Then once again this must be also white. Why? Because capital I is there. And the last one, there is no capital I, means there is no dominant epistatic gene. So that obviously you can expect different white. This is completely recessive white, but this is a different white. So that I am using blue colored. So let us try to know how many of these 16 are white plumaged, how many of these 16 are colored plumage, and the last one different white. So let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that there are totally 12 whites. Look at it. Otherwise I will write here. 12 whites. Okay. And ratio I am writing. Next, how many colored? How many of these 16 are colored? 1, 2, 3. So that let me write here 3. These are colored, and the last one is there. Though it is white, it is a distinct, discriminatory white from the 12. So that I write it with the blue color here. It is one only, so different white. So in some books it is given ratio like 13 is to 3, but according to our geology, this one example, animals example, I want to differentiate the whites amongst two whites. One is leghorn white, another one is bandote white or white bandote. So that 12 absolutely white, and last one is ivory white. Andre anedantina bilupina color anta ನೀವು ವರ್ಣ ಅಂತ ತಿಳ್ಕೊಳ್ಳಬಹುದು, and the in between 3 of them are color plumage fowls. This way we want to say that though it is a dihybrid ratio, unlike a Mendelian dihybrid cross, here we obtain 12:3:1 instead of 9:3:3:1. So this way dominant epistasis is very well explained and justified by considering an example of plumage color in case of fowl, particularly by taking leghorn white and bandote white plumage fowls. I hope you followed this. ದಯವಿಟ್ಟು ಇದನ್ನ ಸ್ವಲ್ಪ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಹೋಗಬೇಡಿ. ಎವ್ರಿ ಟೈಮ್ ಈಚ್ ಎಕ್ಸಾಂಪಲ್, ಈಚ್ ಕಾನ್ಸೆಪ್ಟ್ ಈಸ್ ಡಿಫ್ರೆಂಟ್. ಸಪ್ಲಿಮೆಂಟರಿ ನೋಡಿದೀವಿ ಮುಂಚೆ, ಸೆಕೆಂಡ್ಲಿ ಕಾಂಪ್ಲಿಮೆಂಟರಿ ಜೀನ್ಸ್ ನೋಡಿದೀವಿ, ಈಗ ನಾವು ಡಾಮಿನೆಂಟ್ ಎಪಿಸ್ಟಾಟಿಕ್ ಜೀನ್ಸ್ ನೋಡಿದೀವಿ. ಸೊ ದ್ಯಾಟ್ ಫಾರ್ ಈಚ್ ಒನ್ ವಿ ಟುಕ್ ಡಿಫ್ರೆಂಟ್ ಎಕ್ಸಾಂಪಲ್ಸ್. ಓಕೆ, ಸೊ ಲೈಕ್ ಹೌ ನಾವು ಇನ್ನೂ ಕೂಡ ಮುಂದಿನ ಸೆಷನ್ ನಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತಿದ್ದೀವಿ, ದಟ್ ಈಸ್ ಲೈಕ್ ರಿಸೆಸಿವ್ ಎಪಿಸ್ಟಾಸಿಸ್. ಅಂದ್ರೆ ಎಪಿಸ್ಟಾಟಿಕ್ ಜೀನ್ ತನ್ನ ರಿಸೆಸಿವ್ ಸ್ಟೇಟ್ ನಲ್ಲಿ ಇದ್ರೂ ಕೂಡ ಹೇಗೆ ದಾದಾಗಿರಿ ಮಾಡ್ತದೆ. ಡೋಂಟ್ ಮಿಸ್ಟೇಕ್ ಮೀ, humorously I say, like though the epistatic gene is in recessive state, how can it suppress or how can it mask, how can it inhibit the expression of another hypostatic dominant gene? We will learn it well with greater interest by taking different example. And I hope you followed the entire explanation about this epistasis phenomenon as well as the dominant epistasis with an example. ದಯವಿಟ್ಟು ಯಾಕೋ ತಾವು ಸ್ವಲ್ಪ ಲೆಕ್ಚರ್ ವಿಡಿಯೋನ ನಾವು ಅಪ್ಲೋಡ್ ಮಾಡಿದ್ರು ಕೂಡ ನೋಡೋದನ್ನ ಸ್ಲೋ ಮಾಡಿದ್ರಿ. ವಾಟ್ ಐ ಥಿಂಕ್ ಇನ್ ಅ ಪಾಸಿಟಿವ್ ವೇ, ಲೈಕ್ ಪ್ರತಿಯೊಂದನ್ನು ನೀವು ಕಂಪ್ಲೀಟ್ಲಿ ನೋಟ್ಸ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದೀರಿ ಅಂತ ಅನ್ಕೋತೀನಿ. ಬಟ್ ಡೋಂಟ್ ಫಾರ್ಗೆಟ್ ಟು ವ್ಯೂ every uploaded video lecture on different concept. Thank you. Stay well at home.